Good morning, welcome back. Okay, in this video, we're going to do a bunch of scientific notation examples. So I'm going to pull number 1 from each section. We're doing 4 things, so we're going to do 4 number 1s. And in each section, you're going to choose 5 more. So this is scientific notation, examples, and this is all like from your homework. So we're going to do the number 1s here. Do number 1s. If you wanted to, you could do a number 1 with me, pause the video, do 5 more on your own, do another number 1 with me, pause, do 5 more. You'll do 5 more from each section. There are 4 sections. I'll show you as we go. Section 1, we're off and running. Expanded form to scientific notation. Okay, question 1 says, so this is section 1. I'll do it like this, 4 sections. Here's number 1 from section 1. This is 923. We're going to write that in scientific notation. The implied decimal is just to the right of that last number. We are going to pick up our decimal and put it in between our first 2 significant figures. So pick up that decimal, move it 1, 2. We're going to write an equal sign because that's the same exact thing. We've got 9. We just moved our decimal here, 9.23. And we're going to write this in scientific notation. Each place value is a 10. We moved our decimal 2 times, 1, 2. Moved it 2 times. 923 is a big number, so our exponent of 10 will be a positive 2. Feel free to redo that if you would like to think through any of those steps. I'm going to move on to section 2. I'm just going to do number 1 from each of 4 sections. Section 2 is on that same page, and it says, convert the following numbers into standard notation. Standard notation is expanded form, is what they're both the same thing. So convert the scientific notation into standard or expanded form. The first one of this section is number 9. They give you 3.9240 times 10 to the 5th. You might notice those are ending zeros after a decimal. Those are significant zeros. Interesting. Okay, just keep that in mind. We are writing this in expanded form, so we're going to pick up that decimal and move it, each place value is times 10. We're going to move it 5 place values. We've got a positive 5 there, which means this is going to be a big number. So we're going to pick up our decimal, we're going to make that number bigger, we're going to move the decimal to the right, and we want to move it 5 times. Off we go. 1, 2, 3, 4, 5. So our decimal is going to wind up over here, equals 39240. Those are significant zeros. Technically, you want to put that decimal right there to show that they're still significant. Now, you're going to ask me the question, if I didn't think of that, or that didn't come to mind at all, and I just didn't write that decimal, are you going to mark it wrong here? No, I'm not. But if you're thinking about it and you're like, oh, like clearly these are like significant because we wrote ending zeros after a decimal, I'm gonna show that I know that they're significant. Totally go for it. This is technically more correct. I get it that this is sometimes a little tricky. I mean, it's tricky in person also. I would take both of these as being correct answers. And the reason is that right here we're learning scientific notation, so like mostly I want you to learn the scientific notation. If you're also thinking about the significant figures, great. If you're going on any science field, thinking about significant figures is an awesome thing to do. And once you get the groove of it, it goes real smooth. But like in this class in high school, either of these are correct answers. We can totally chat if you're like, how on earth are there 2 correct answers to my math question? Because I get it that can be confusing also. All right. We're going to do number 1 from our next section, which is on a different page. This page has a friendly butterfly on it, going like, yeah! I don't have to draw the butterfly while you're like sitting here watching me do this lesson, and that's not a very nice butterfly. Okay, butterfly! Sorry. This one says, these are multiplication and division, so we've got 9.32, I've never noticed that that's like the same number almost, times 10 to the 3. Okay, here's something that sometimes trips people up. You see that these 2 parentheses are next to each other? That means multiply. So like, if you'd like, you can write in a multiply sign, but since like every time those 2 parentheses are next to each other, it means multiply. Our second number here is 3.32 times 10 to the 2. Okay, so we are multiplying in scientific notation. Just like our other video, we're going to break this into calculator numbers and scientific notation numbers. Calculator numbers go together. This is a multiply question, so you've got 9.32 multiply times 3.32. So those are our calculator numbers. We can punch that into a calculator, and that is a great option. And then we have our scientific notation numbers. We've got times 10 raised to the 3rd power times 10 raised to the 2nd power. And even though that does look kind of gross, you're getting used to it. I'm just going to use my calculator, 9.32 times 3.32, and that gives me this number, 30.9424. Here's my scientific notation. I will come back to that, don't worry. I've got 10 times 3, or 10 to the 3rd power times 10 to the 2nd power. This is the last time I'll write this out, but that 10 raised to the 3 is 10 times 10 times 10. 10 raised to the 2 is 10 times 10. 1, 2, 3, 4, 5. 10 raised to the 5th power. Yeah. What was I going to say there? Oh, or you can just add the exponents of 10. This is why it works, but it does work. You can just add them. Cool. We said we come back to this number. This is a technically correct answer. I mean, I would accept this as a correct answer in this class. We have right here. We're going to make it more correct. Here we go. This number has 3 sig figs. This number has 3 sig figs. Our answer is going to have 3 sig figs. Keep the biggest 3, round using the next one. Keep biggest 3, round using that 4. The 4 is going to round down. This is one step more technically correct. My light moved, and I feel like it's even worse than it used to be in terms of being able to see stuff. Okay, let's try that. This is even more technically correct. Times 10 to the 5th. But you know that with the scientific notation, you want your decimal over here. You want it between your first and second significant figures. Okay. Times 10 to the 5. That's just going to come along for the ride. We just moved our decimal 1 time. So there's going to be something about scientific notation here because we moved it 1 time. And we went from a big number, 30.9 is big, 3.09 is small. We moved it 1 time. We're going to make our exponent 1 bigger. Since this, we moved our decimal 1 time to make our number smaller, we're going to change our exponent 1 time to make our number bigger. feel free to rewind and re-listen to that, or ask, or you don't have to. So again, so this is the most correct answer. In this class in high school, this is also a just fine answer. This is a just fine answer. I mean, this is a just fine answer. Any of these places that resonate for you are fine. Yeah, I'll just leave you with that. You can choose which level you want to kind of take your answer to. Our fourth section is that same butterfly page, and at number 6 we're going to start dividing. Number 6 says 5.26 divided by, they actually write the division sign, which is nice. You can tell me, and you are correct, that 11.1 is not incorrect scientific notation. You do not need to correct them. Off we go. We're going to do this one the same way. Here are our calculator numbers. So we've got 5.26 divided by 11.1. Here are our scientific notation numbers. You know, I'm going to write this as a multiply because it kind of is. Okay, here's our scientific notation. We've got times 10 to the 5 divided by times 10 to the 3. Okay. Calculator numbers, go in the calculator. 5.26 divided by 11.1. Scientific notation numbers are what we're kind of really doing here. Times 10 to the 5 divided by times 10 to the 3. When you're dividing in scientific notation, subtract your exponents of 10. Let's do some sig figs on this. This has 3 sig figs, this has 3 sig figs, and your answer is going to have 3 sig figs. Keep the biggest 3 place values around using the first place value you're not going to keep. 8 rounds up. You're going to get that. Times 10 to the 5 minus 3 is 2. This is a great answer right there. You might notice this is not incorrect scientific notation. You want to move your decimal 1 over here. We move our decimal 1 time. 4.74 times 10. Keep that 10 for the 2 along for the ride. We just moved our decimal 1 time. We have to figure out if that's a negative 1 or a positive 1 right here. We 0.74 is small. We went from small to big. 4.74 is big. We moved our place value 1 time to make our number bigger. So we're going to move our exponent of 10 1 time to make it smaller. And come out with a final answer. Other than that. Okay. Now, again, like, this is fine as an answer, although you probably can realize that some of those are not necessary. This is fine as an answer. This is fine as an answer. This is fine as an answer. This one is most correct, but if any of these steps are like, how did she get there? You can leave your answer somewhere over here, and that's okay too. All right. So you are doing several more as practice questions. Do 5 more from each section. So And I'll do all of them in the answer key video, but you choose 5 more from each of these 4 sections. You're doing 20 questions. Half of them are things like moving decimals. A quarter of them are adding exponents, and a quarter of them are subtracting exponents of 10. See you soon. Enjoy.